Today we're looking at binomial expansion, and there's a couple of things we need to go through first. Pascal's triangle and factorial notation, which we'll use when we do binomial expansion. Binomial expansion is actually the expansion of two terms raised to some power. So for example, 4 plus 5x to the power of 10. What would that look like? How many terms would it be? What are the coefficients of each term, and so on. We can then use binomial expansion to do an estimate of a value raised to a power, and that's where binomial expansion is quite useful. So, a couple of things for you to do first. Can you work out the expansion of a plus b squared? That should be pretty straightforward. And then a plus b cubed, can you work that out? Then just have a look at those two expansions. Is there a way that you could predict what a plus b to the power 4 is? Okay, so just pause the video, have a go at those tasks, and then resume in a moment. Okay, so a plus b squared is pretty straightforward, although quite often students make the mistake of writing a squared plus b squared, which isn't quite right. So you need to expand the brackets properly. So a plus b times a plus b, you're going to get an a squared, you're going to get a 2ab when you combine your like terms, and a b squared. Okay, now a plus b cubed, you could write down a plus b cubed as a plus b squared times a plus b. So if we take our first expansion, like so, and multiply that by a plus b, so you can multiply all of the terms in the first set of brackets by a, and then all of the terms in the first set of brackets by b, and then combine like terms. What you'll end up with is a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, now if you have a look at these two expansions, you can see, just looking at the number of terms, in a plus b squared we have 3 terms, and in a plus b cubed we have 4 terms. So you might suppose that in a plus b to the power 4 we would get 5 terms. And actually you would be correct. The number of terms is 1 more than the power, and you'll see that in a moment. Now, what about the actual powers of a and b? Is there a way that we can predict them in the expansion? Well, if you look at this first expansion, you can see we've got a squared, and then a to the power of 1 in the middle term, and then in this third term we could think of it as a to the power 0 times b squared, and a to the power 0 is 1. So the powers of a decrease from 2 to 1 to 0, and in a similar way the powers of b increase from b to the power 0 in the first term to b to the power of 1 to b squared. And that works in the second expansion as well. So we have a cubed, a squared, a to the power of 1, a to the power of 0. So the powers of a decrease and the powers of b increase. Okay? So combining those two facts, we could actually have a good guess at what a plus b to the power 4 would look like. The only thing we'd struggle with is the coefficients, the numbers in each of the terms. Okay, so in the first term we've got 1, so in the first expansion we have 1, 2, 1. In the second expansion we have 1, 3, 3, 1. So is there a way of predicting what those numbers would be? And there is, and there's a way of calculating them as well, and I'm going to show you how to do them in a moment. So here we have the first 6 expansions of a plus b to the power of n, where n is from 0 to 5, and you can see it forms this nice triangle. Okay, and a plus b to the power 0 is just the value 1. Okay, a plus b to the power 1 is just a plus b, and then we've done a plus b squared, a plus b cubed, a plus b to the power 4. That was the question. What does that look like? Well, you can see it starts with a to the power 4, and then a cubed, a squared, a to the power of 1, a to the power of 0. So it works for a plus b to the power 4, decreasing the powers of a and increasing the powers of b as well. Okay, so b to the power 0, b to the power 1, b squared in the third term, b cubed, b to the power 4, and so on. and it follows that the same thing happens in a plus b to the power 5. Okay, so the only question remains, how about these numbers? What about these coefficients in each of these expansions? How could we work out those coefficients? Well, if we just highlight the coefficients, I've highlighted them in blue here, it forms this nice kind of symmetrical triangle. You can see it's symmetrical about the middle. So we've got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. It's symmetrical about the middle. So if we can work out the first half of the row, then the rest of the row is just the same but decreasing. Okay, here I've just highlighted the actual numbers, and this forms what we call Pascal's triangle. Okay, Pascal was quite a famous mathematician, and he came up with this idea. And Pascal's triangles is used in a lot of different areas, in statistics and mechanics and so on. Okay, so how would we go from one row to the next? How is this triangle formed? Well, it's actually quite easy, because you can see we have a 1 at the start of each row, we have a 1 at the end of each row, and the number in between two numbers in the preceding row is just the sum of those numbers. So 2 is the sum of 1 and 1. Here we have 3 in this row is the sum of the two numbers above it. Let's try one down here. 10 is the sum of 6 and 4, the two numbers above that. Okay, so there is a way of working out Pascal's triangle, but it's kind of tedious. It would take a long time. If we had to work out a plus b to the power of 20, for example, we'd have to do each row one at a time and try and work out those numbers, or possibly use a lookup table. But there is a way of working it out on your calculator, and that's what I'm going to show you next. Incidentally, before we move on to that, here we have something called Sierpinski's triangle, and it's formed from Pascal's triangle by shading all the odd numbers. What we end up with is this fractal type image. Okay, so you can imagine this triangle as being a smaller version of the bigger triangle, and so on. Okay, it's a fractal. Sierpinski's gasket is another name for this. And there's quite a lot of information on YouTube and Google about fractals. It's quite an interesting topic. Okay, so a couple of buttons on your calculator. We have this n exclamation button, and what this means is n factorial. Okay, so n factorial is how we would say that in mathematics. And it means n times n minus 1 times n minus 2, and so on until you get to 1. So for example, if we had 4 factorial, that would be 4 times 3 times 2 times 1. Okay, and that is something you need to remember. NCR. Okay, this is a button that's used quite often in statistics, and it's a way of choosing. It's a way of working out how many ways can you choose R items from n items. So imagine you had a group of 5 people, and you wanted to pick 3 people out of that 5. How many ways could you do that? Well, that is, you can use this button to do it. Okay, we use the word choose in maths, so n choose R. Or alternatively, you might see it like this. Okay, so kind of like a vector notation, but in the right context, it means n choose R. So, for example, if we had, let's say, 5 choose 3. Okay, there is a formula for it, and in this particular example, it would be 5 factorial over 5 minus 3 factorial, 3 factorial. So we would do 5 times 4 times 3 times 2 times 1 on the top row, and underneath 5 minus 3 is 2, so you get 2 factorial. Okay, let's just write that out. Okay, so you get 2 factorial, which is 2 times 1, and then 3 factorial, which is 3 times 2 times 1. And you can simplify this calculation just by cancelling those two there, and then 5 times 4 is 20 over 2 times 1, which gives you the value 10. Okay, so 10 ways of choosing 3 people out of a group of 5 in that particular example. The general formula for NCR is n factorial over n minus r factorial r factorial. Now this will give you a coefficient of one of the terms on a particular expansion. Okay, so n is going to be the power of your expansion, and r is going to be the number along the row of the term that you're trying to work out the coefficient for. So I'll do some examples of that in a moment. Incidentally, folks, if you wanted to use your calculator to do this, then let's just do this particular example here. So press the number 5, and then you'd have to press Shift, and then the divide key, so that just gives you the NCR button above the divide key on your Casio calculator, and then 3. And when you do that shift divide, you get the letter C. So on the screen you would see 5C3, and then you press equals, and that gives you the value 10. Okay, so that's how you use your calculator. Let's just show you the general expression for a binomial expansion of a plus b to the power of n. So we start off with the coefficient. So nc0 is the first coefficient. Then we get a to the power of n, b to the power of 0. Okay, so b to the power of 0 is just 1, so we could just ignore that bit if you want. The second term would be nc1, which you can work out on your calculator. A to the power of n minus 1, b to the power of 1. Okay, I'll leave the 1 out. nc2, a to the power of n minus 2, b squared, and so on. Okay, all the way up to the last term, which would be ncn, b to the power of n. Okay, just squeeze it on the end of the screen there. Okay, so that is the general expansion. Now, you can easily write out a to the power of n, a to the power of n minus 1b, a to the power of n minus 2b squared, and so on. You can write down all of those terms. You can then work out the coefficients of each term and put them in, so you get the full expansion. Now, in the formula book, you do get both of these. You get the expansion of a plus b to the power of n, okay, so you don't have to remember that, and you do get the formula for NCR, okay, so you don't have to remember that as well, but it is quite useful to remember these. In the upper sixth, we spend more time looking at this particular expansion. This is the expansion of a plus b to the power of n when either a or b have the value 1, okay. When that's the case, then our general binomial expansion will simplify to this expansion. And it might look a little bit more complicated, but it's actually really easy to use, and you can use it in more situations. So for example, you can use it when n is a fractional or a negative power, but you can't do that for a plus b to the power of n. N has to be a whole positive number. Okay, so something to look forward to in upper sixth binomial expansion. Let's have a look at an example. In example 1, we need to fully expand 2 plus x to the power of 5. Now, if the power is 5, what would be the number of terms? Well, remember it's 1 plus that power, so it is 6. I'm going to use the notation NCR instead of the brackets. It doesn't really matter, but I prefer to use NCR. And what I'm going to do is I'm going to write it like this. I'm going to first of all start off with the expansion of a plus b to the power of 5. And then I'm going to substitute for a, I'm going to substitute 2 for a, and x for b. So just starting off with this expansion, And because I need 6 terms, I'm just going to start by writing out 6 terms. I call this the Cabba method. Okay, 1, 2, 3, 4, 5, 6. We're going to start off by putting this power 5 on the top left of the C. So we have 5 there, and that's the same all the way across. So we've got 5s there, and then the bottom right of the C, we start off with 0, and incidentally that's the power of b as well, and then increase it by 1 each time. So 5c2, b squared, 5c3, b cubed, and so on. 5c5, ab to the power 5. And then the powers of a, they start at 5 and they decrease as we go down. And you'll probably notice that the powers of a and b both add, in each term, add up to the power that we're taking our binomial expression to. So 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, and so on. Okay, now we need to just work out these coefficients, and a couple of tips for you. The first coefficient is always 1, so this first term is just going to be a to the power 5, and the second term is going to be the power, so 5c1 is actually the value 5. Okay, 5c2 is, you can put that into your calculator and work it out. It's going to be 10. And then, because we're halfway, we can just then reduce those coefficients. So we're going to get a 10 a squared b cubed for the next term, a 5a b to the 4, and then the 1 for the last term. So I'm just going to write down b to the power 5 for that last term. Okay, so that's the expansion of a plus b to the power 5. What we need to do now is to replace a with 2, and we replace b with x. So we can work out what our expansion is first. I find this method kind of reduces the number of errors that you will make. If you try and do it all in one go, you can tend to make mistakes more often than using this kind of approach. So that's what I would recommend. 2 to the power 5 is 2, 4, 8, 16, 32. And then we got 5 times 2 to the power 4, which is 16. And then b is x. I'm doing the little dots here. That just means multiplying. That's just another bit of mathematical notation you should be aware of. 10 times a cubed, 2 cubed is 8, x squared, 10, a squared is 4, remember a is 2, run out of space here, 5 times 2 times x to the power 4, let's put this last term just underneath here. That's just going to be x to the power of 5. Okay, make a little bit more room. Now we just need to work out what these coefficients are. So 32 for the first term, 5 times 60 is 8, 16 is 80, 10 times 8 is 80 as well, and then 40 x cubed, and 10 x to the power 4, and then just x to the power of 5 for the last term. And that's it. There you go. So 6 terms, the full expansion of 2 plus x to the power of 5. In example 2, we need to work out the expansion of 2 plus 3x to the power of 6. And we're told that that's approximately equal to a plus bx plus cx squared, where a, b and c are integers to be found. So I'm going to start off by doing the expansion of a plus b to the power of 6. and I'm just going to do the first three terms, and then I'm going to work out the expansion of 2 plus 3x to the power of 6. Okay, so remember, start off with the power to the top left of the C, and 0, 1, and 2. And of course, we would have a number of other terms after, but we're not interested in them. The powers of A will start at 6 and decrease. And now we just need to work out what the coefficients are. So 6C0, remember I said the first term is going to be 1 always. So this first term is just a to the power 6. Second term is just going to be the power, which is 6 in this case. And then the third coefficient is going to be 6C2, which you can just type into your calculator and work out. That's the value of 15, a to the power 4b squared. So they're the first three terms of our expansion of a plus b to the power of 6. Now we're just going to replace a with 2 and b with 3x and work out what the expansion, or at least the first three terms of 2 plus 3x to the power of 6. Okay, so just replacing a with 2 and replacing b with 3x. I'm going to put brackets around 3x, okay, because another common mistake that students make, I'll show you, is not squaring. In this case we need to square the 3 and the x. Okay, if you didn't put brackets around the 3x, then you would be tempted to just square the x and not the 3 as well. So we need to do that. Okay, 2 to the power 6 is 64. 2 to the power 5 is 32 times 6 is 132, but we need to multiply that by 3 as well. So that gives us 396. And then here we're going to do 15 times 2 to the power 4, which is 16, times 3 squared, which is 9. And that gives us a value of 2,160. Okay, so if we compare that to the expansion in the question, we can see that A is going to be the value 64, B is 396, and C is 2,160. Just write that down. And that's it. In example 3, we need to write down the expansion of x minus 2y to the power of 8 up to and including the x cubed term. And you'll see when we do this, we actually need 6 terms in total. Now I'm going to start by doing the expansion of a plus b to the power of 6 to the power of 8, sorry. And then we'll substitute in for x minus 2y after. Just remember the powers have to add up to 8, and this number at the bottom is just increasing. The powers of A decrease, the powers of B increase. And then you get quite quick at it with a bit of practice. Here we've got an a cubed term, that's going to be our x cubed when we substitute in x and minus 2y. So 6 terms in total. Let's just simplify these terms before we substitute. Let's just work out the coefficients. Well, the first one's always going to be 1, so that first term is just a to the power of 8. The second term is the power, The coefficient is the power, which is 8. So 8 to the power 7b. Then we need to start using our calculator. Now 8c2, if you use your calculator, gives you the value 28. And 8c3 is the value 56. And 8c4, which is exactly halfway through the whole of the expansion, has got the value 70. And then we start to reduce the coefficients again. So the next coefficient is going to be 56, and then 28, and then 8, and so on. Okay. So 56 a cubed b to the power of 5. So there's our 6 terms in our expansion of a plus b to the power of 8. Let's just work out what the expansion of x minus 2y power of 8 is by replacing a with x, okay, and b with minus 2y. This is one of those type of questions where you do need to take your time, be precise, keep it neat, double check as you go along, because one mistake at the beginning is going to filter through right to the end. And you'll notice I'm putting brackets around minus 2y. That's particularly important because we're raising that to a power. So it's not only going to change the sign, it's going to change the value of the 2, because they'll have 2 squared, 2 cubed, and so on, and we'll be raising y to the power as well. So here we've got minus 2y squared, that's our third term. Minus 2y cubed is our fourth term. And I'm just going to pop this last term underneath. Okay, let's just make a bit more space. And now we can start to simplify these terms. So x power of 8 for the first term, minus 2 times 8 is minus 16. X power 7y. Minus 2 squared is 4, and 4 28s are 112. Now you'll notice also that we start off with positive, then negative, then positive, then negative. You'll get that when you have a negative term. Okay, so 112 x power 6 y squared. The next term is 448 x to the power of 5 y cubed. So the next term will be positive. 1120 x to the power of 4 y to the power of 4, and then the last term should be a negative. Let's just change that. We're going to get minus 1792, and some of these numbers will be fairly big, don't worry about that. Okay, so there you go. So there's the expansion of x minus 2y to the power of 8 up to and including the x cubed term. So this last term here has got the x cubed in it, and that's where we need to stop. Now of course there would be some more terms after that, but we're not asked to work them out in the question. In example 4, we need to work out the first 4 terms in the expansion of 2 plus x over 3 to the power of 9. So I'm going to start off by working out the expansion of a plus b to the power of 9, and then we're going to substitute 2 and x over 3 into that. So only need 4 terms, so I'm just going to do 4 cabs here. Now the power goes on the top left of the C, so let's put them in. And then 0, 1, 2, 3. And then just fill in the powers of A, 9, 8, 7, 6. Okay, let's work out the coefficients and just simplify each term. So 90 is 1, so that first term is just a to the power of 9. 91 is 9. 92 is the value 36. And 93 is the value 84. Okay. At this point, I just double check, make sure you've worked those values out correctly. Okay, let's go ahead and substitute our values of 2 and x over 3 in here. So we're going to get 2 to the power of 9, 2 to the power of 8, times x over 3, 2 to the power of 7, x over 3 squared, and then 2 to the power of 6, and x over 3 cubed. Okay, and don't forget to cube the 3, or square the 3 in each case. Okay, right, so we just need to pop these in our calculator and work them out. So the first term is 512. Second term, 9 times 2 to the power of 8 divided by 3 is 768. (36) times 2 to the power of 7 times x squared over 3 squared gives you also 512. And then finally we have 1792 x cubed over 9. That's it. Okay, I'm going to give you a moment to try this one. Just take your time, be careful. We only need 3 terms, so don't do more than that. And you can pause the video and I'll go through it in a moment. Okay, so hopefully you've managed to figure this out. Let's just start off with a plus b to the power of 10. So we're going to get 3 terms. And put in our power first. Yep, and then 10, 9, 8. Okay. So first term is a to the power of 10. Second term is 10, a to the power of 9b. Third term, 10c2 is 45. Okay. So we're going to get an x squared to the power of 10, a 10 times x squared to the power of 9 times minus 1 over x, okay, because we've got a negative term, we're going to expect each term to change sign. (45) x squared to the power of 8 times minus 1 over x squared. So x squared to the power of 10, remember you multiply the indices together, so this first term is actually x to the power of 20. Now we've got a negative 10, x squared to the power of 9 divided by x. So x squared to the power of 9 is x to the power of 18, but if you divide them by x, that's going to give you x to the power of 17. Subtract 1 off the indices there. Then we have 45. X squared to the power of 8 is x to the power of 16, but we're dividing by x squared, so that's x to the power of 14. Okay, hopefully you got that right and you're getting the hang of this now. Okay, another one for you to try on your own. Have a go at this, and this one I'll actually be going through in class just to make sure that you've got the hang of it. So do this one for homework and bring your answer in to class. And as a bit of practice, have a go at exercise 8C on page 164, and again bring your solutions to class so that we can go through any problems that you have. Okay, I'll see you then.